So now let's go ahead and talk about some of the key methods that are defined in the Java ExecutorService interface. And you'll see that many of these methods are used to submit one or more tasks to be executed asynchronously in the underlying implementation of the executor service, which is typically some type of thread pool. There's a couple of methods that are very simple. In fact, one is just inherited directly from executor itself. So the execute method, as we'll see in a moment, is coming straight from executor, and we already know what it does. The other method that we'll talk more about, because it's more interesting, is called submit. So again, just a quick recap, execute will run a one-way task that doesn't return anything. That's what makes it one way. In practice, this method really isn't that useful because you have no easy way to control the life cycle of the task because it's going to run in the background, and short of shutting down the entire executor service, there's no easy way to cancel that running task. Therefore, the executor service also defines the submit method. And submit runs a two-way async task that returns a value via a future. Remember that proxy that we talked about before. This method is much more common, much more useful in practice because now you've actually got a way to control the life cycle of the task that you've been submitted for execution in the background. Now, this particular model, the submit method we see here, supports something called the synchronous future processing model. And you'll see why we call it that shortly. And you'll also see that there's another model that we'll talk about, which is the asynchronous future processing model. And that will be something we'll discuss in more detail in a later set of lessons. The get method defined on future can block, if you call it in the form that takes no parameters, until the task completes successfully. At that point, get will return the results of the task, which could be the result, that's the value if it succeeded, or it could be an exception if the computation failed. Submit can also run a one-way async task that returns no values. You can also submit a runnable. You might ask, how does that differ from the execute method? Well, the main difference is that the execute method doesn't return a future, so there's no easy way to cancel the asynchronous task, whereas in contrast, the submit method that takes a runnable does return an asynchronous future. And so as a result, you can, or a future to an asynchronous computation. So in fact, you can cancel that. So it's a little bit more useful, even if it only does one-way computations. There's also a couple of other methods defined with executor service that can be used to execute groups of tasks. And these methods are the Invoke All and Invoke Any methods. These methods can take, or actually do take, collections of callables. So if you have a collection of callable objects, then you can pass them wholesale into the Invoke All or Invoke Any methods, and they will do their thing on the collection. One of the things to remember if you use Invoke All or Invoke Any is that you shouldn't modify any of the contents of the collection while the operations are running, because otherwise chaos and insanity will break out because of Java's pass-by-reference semantics. So let's first talk about Invoke All. What Invoke All does is it goes ahead and it takes all the callables in the collection passed as a parameter called tasks, and it will go ahead and run all those things. And when it's done, it's going to give back a list of futures to all the tasks that completed. And all the futures in this list that is returned are actually done. So we don't have to worry about blocking on them when we go to get the values. And the reason it returns a list of futures as opposed to a list of objects is because that way we can indicate easily whether or not the task completed successfully or unsuccessfully. If they completed successfully, then when you call get, you'll basically get the value, the result of the task. If they threw an exception, then you'll get an exception when you call get. So that's a way to indicate that. There's also the Invoke Any family of tasks. And Invoke Any return the result of one successful computation. And this is useful for concurrent algorithms that just want whatever result finishes first. So you can imagine some kind of a search operation where you're going to go off and do like a MapReduce style computation where you're going to query a bunch of different databases. And all you want is the first result that comes back. You don't want more than one. You also might imagine maybe some kind of game playing algorithm like finding a path through a maze or computing the best move in a chess match or whatnot. And you just want, or finding the best flight for the cheapest flight for a bunch of airlines. So you just want the first one. Invoke any will give you back the first one. And it cancels all the tasks that haven't completed yet. So whatever result comes back, we cancel all the other tasks so that they will hopefully shut down and not chew up CPU resources computing results that are unneeded. If there are other completed tasks, in other words, since it's done concurrently, there could be other things that finish at roughly the same time. All of those other completed tasks are simply ignored. We just take the one that comes back first, whatever first means in this context. These methods block the caller. So it can be a little bit non-intuitive. You might think invoke all will start all the tasks running and then return right away. Well, that's actually not the way they work. These methods will block until they get all or any of the results, respectively. There's also overloaded versions of invoke all and invoke any that can be given a timeout. So it says, wait for this amount of time for the computations to finish, and either you get them all, you get any, and if that time period elapses, then return. And of course, you'll find out what the results are when things come back. When invoke all doesn't time out, in other words, when it finishes before the timeout period, then the list that comes back will indicate everything that finished. In contrast, if it did time out, some of the tasks may not have completed. And if they haven't completed by the time the timeout elapses, then they're going to be canceled. So you'll get back a list of things that actually completed. Likewise, with invoke any, if the timeout elapses, the timeout exception is thrown. So that's an indication that you didn't get a result at all before the timeout elapsed. So that's the end of the overview of some of the key methods in the Java Executor Service interface. And we'll talk about other methods because believe it or not, there's actually many more. And we'll cover those in part 2 here in just a moment.